All right, today we've got equations of lines and modeling. Actually, today we're just going to do the equations of the lines, save the modeling for tomorrow. All right, slope, intercept, equation of lines. You know from your past experience and even the other day that slope-intercept form looks like this, y equals mx plus b. And the best time, really the only time to really use it to start a problem with is if you know both. If you know the slope and the y-intercept of a line, then it's great to use because you can just plug the slope right in for the m, and this y-intercept is 0.16, so the y-intercept is 16, and that's all you have to do. All right, so slope-intercept is great when you know the slope and the y-intercept. If you don't know the slope and the y-intercept, the best thing to do is something called point slope, because point slope is more useful than slope-intercept because you still have to have the slope, but you can use any point on the coordinate plane, not just the y-intercept. So what I'm going to do first well, let's read the problem. Find an equation of the line containing the points 2, 3, and 1, negative 4. Now, you need a point and the slope. So I'm going to find the slope first. Remember, it's y minus y over x minus x. So my slope there is going to be 7 over 1, which is just 7. Now, it's your pick which point you want to use. Doesn't matter. I'm going to pick this one just because they're both positive, I guess. That's my only reasoning there. So I'm going to do y minus the y coordinate, the slope times x minus the x coordinate. And that looks like a bad parentheses. And so what I'm going to do next is, that didn't help. I'm just going to distribute and put my answer in slope-intercept form. So distribute the 7, make it 7x minus 14. And one more step, just move the 3 over. It becomes positive 3, negative 14 plus 3 is a negative 11. And that's it. Point slope form. You use that a whole lot more in slope-intercept, mainly because it can use for any point, not just the intercept. A couple of big sentences here. Non-vertical lines. All vertical lines are parallel, but non-vertical lines are parallel if they have exactly the same slope and different y-intercept. So mainly the slopes are the same. Perpendicular lines are lines whose slopes are opposite reciprocals. So it means you change the sign and flip the numbers, or if you multiply their slopes, you get negative 1. The only way you can multiply two numbers and get negative 1 is if the two numbers are opposite reciprocals. Okay, what they're going to do next is say determine whether the following pairs of lines are parallel, perpendicular, or neither. So the first one, part A, I'm going to take the 2 to the other side there and make it in slope-intercept form, make it 5x minus 2. On the second one, I'm going to take the x across. It'd be 5y equals negative x minus 15. Divide everything by 5, get negative 1/5 x plus, minus 3. I'm mainly looking for the slopes anyway. The slope of that one's 5. The slope of that one is negative 1/5. Because they're opposite and reciprocals, those two would be perpendicular. So part A, would call perpendicular because the slopes are opposite reciprocals. All right, let's try the next one. Part B, do the same steps. I'm going to put them in slope-intercept form. So on B, first thing I'm doing on this one is moving the 4x to the other side. 2i equals 8 minus 4x. I should have put the 4x first. Divide everything by 2. I'll rearrange it now. Be negative 2x plus 4. So that's the first one. Do the same thing here. Moving the 5 to the other side. No, I'm not. Sorry about that. Made a mistake. That's okay. The y is already by itself. It just needs to be positive y. So I'm going to multiply both sides by negative 1 and get it looking just like that. Now, even though it doesn't look like it's slope-intercept form just means y is by itself. So slope of that one's negative 2. Slope of that one's negative 2. They're both the same. That means those two lines are parallel. And let's look at one more, part C. Part C, the good thing about part C is the first equation is already in slope-intercept form, y equals 2x plus 1. The second one, all I have to do is move the 3x over. Now we get negative 3x plus 4. Compare the slopes, that's 2, that's negative 3. The slopes are different. They're not opposite reciprocals, which means they are neither parallel or perpendicular. All right. Write equation of the lines parallel and perpendicular to the graph of 4y minus x equals 20 and containing that point. So we got to do two things here. What I need from this line is I need the slope. So I'm going to rearrange it. I'm going to slide the x to the other side and divide by 4, which would give me a 1/4 x, which is what I need. So my slope there, My slope is 1/4. So if I'm going to do parallel, I'm going to use the same slope, and I'm going to use that point. So there I said point slope. So part A, I'm going to do y minus the y coordinate, which is -3. The slope, which is 1/4, x minus the x coordinate, which is 2. So y minus -3 is y plus 3. Distribute the 1/4. 1/4 times 2 is -1/2. And then to finish that up, I'm just going to move the 3 over. Move the 3 over here, make it a -3. So it's really -3.5. And -3.5 is really -7.5. So that's the parallel one. That's A. I'm going to go to B. I'm going to move this up a little bit. Part B. Now part B, I'm still going to use the same point, so this is going to stay the same, and this is going to stay the same. What's going to change is the slope. Now the slope I'm using for perpendicular is the opposite reciprocal. So since that slope was 1/4, if you do opposite reciprocal, that's going to be -4. So I'm going to put -4 right there. So over here I have a y plus 3. Right hand side a -4x plus 8. And then my last step is just to take the 3 over here, make it -4x plus 5. And that's my perpendicular one. All right, one more slide. Oh, this slide is really awesome. It has pretty much everything we've done the last couple of days. All the terminology over here, all the words are over here, all the symbols, the math language is over here. Really, really good. It's almost like picture worthy, like on your camera or something, because that's a great review slide. But I just want to show it to you. Really good looking stuff. It's everything we've done, so really useful. But we'll work on it tomorrow. All these equations of lines, you did this in Algebra 2 and Algebra 1 probably, so it should be a review for you. Hope it was. I'll see you tomorrow.